All right, you guys ready? Okay, let's get back and rolling here. All right, can you guys hear me fine? Good? All right, good, okay. All right, everybody know the name to the person on the right? To the left? Stand up. Oh, fight. Oh, all right, that's a West Coast thing, but that's right. All right, so we're going to do a little Phil Donahue. Do people remember Phil Donahue? Who's the modern millennial that does these interviews? Any names come to mind? Who's on MTV? Does anybody watch MTV, or at least your kids that watch MTV? Okay. Actually, it doesn't happen on all of that. I found out now it's all on YouTube, and that's where it's happening. So we have a YouTube channel for access management. We also have Facebook, so you guys can go there afterwards. All right, so let's get on with autonomous vehicles and access management. And everybody probably looked at this and are like, oh, autonomous vehicles, that's what we hear about every day, everywhere, and everything that we do. So we wanted to talk a little bit on how it works with access management, and again, that evolution that I talked about earlier of multimodal to the economics, and now we're going to get into connected autonomous vehicles, and we're going to really focus on two areas this morning with our panelists. The first is access connections. And you see we have two examples here we're going to talk a lot about, example A and example B. Mike's been doing access for a while, so I'm going to test him here. So Matt, or Mike, what's the difference in the number of accesses between A and B?
A lot more in B.
There's a lot more in B, so that's why he runs access management here in Wisconsin. All right, so as we drive to these, if we're driving to the restaurant on in part A, you know, what driveway do we turn in? Well, there's only one driveway, so that's pretty easy, okay? So there's an address. After a few cars do that, they figure out where it's at, and we're on our way. Next, you call the autonomous vehicle. I want to go and pick up a burger and a shake there at that fast food restaurant. Which access does the autonomous vehicle go through? You know, there's three accesses, two on the main road, one on the side road. If it's us and we're going through that drive-through, which access, Mike, would we probably go into? Off the main line. That first one, because we know if I want my burger and my shake, I got to go counterclockwise around this building because that's where I get my shake. So that's a little bit difficult for an autonomous vehicle to figure that out. So we're going to talk a little bit about that. The second, and this is something you're starting to see a lot more around the country, and again, evolution of access management, is access to the curb. Has anybody heard of curb management? No, not if, all right, we're going to get to do some learning here today. So we have two examples there. There's an open curb and a closed curb, okay? So how many people have used a TNC? Okay, Uber, Lyft, that's what a TNC is? All right, a few people have used that. Okay, so under the open scenario, what does the Uber driver do? Come on, it's communication. You guys can speak. He pulls right up, drops them off, and you sit there and drink your coffee or eat your food. Under the closed scenario, what does the Uber driver do? Double park, just like the Suburban there. Well, you know, if you program your autonomous vehicle, it needs to get access to the curb. Otherwise, you're held captive until it gets access to the curb. So we're going to talk a little bit more about that and some of the issues that are coming up in a lot of the metropolitan cities around the U.S. with access to the curb, and a lot of the same elements that we did into access management, the conflicts, the multimodal nature, come up with this. So our two panelists today are going to work us through this, and we're going to have a little bit of discussion on that as we go forward. So we're going to go over here and introduce our panelists. Our first panelist sitting to my right, I do know his name, It's Matt. Matt Smith. He made it easy on me. I said, I want the easiest name as a panelist, so Matt, he delivered
No problem.
on that.
I'm here to help.
And our second panelist is John Riehl. And his name's more difficult, but he's like, it's just like fishing. Just reel it in, and we're good. Doesn't look like that in print, but that's what it is. So they're going to help us through today and provide a little bit of background. Matt comes from Michael Baker International, and he heads up their Connected Autonomous Vehicle program on a national level. He's worked both in the consultant field and in state government. He was with that state just across the lake, as I understand here, Michigan. It was with them for about a decade, did traffic engineering, worked on their ITS and autonomous vehicles. And he is, and this is a little bit dangerous in these parts with football season come up, he's a Penn State grad. So, we'll see what they do this year, but he is a proud Nittany Lion with an engineering background from there. So, welcome, Matt.
Thank you very much, Mark. Appreciate it. So I do have to say the best preparation I did was I made sure I wore black socks because I love the setup here. So I'm glad I didn't wear the white ones. That would have been awkward. But great. What I really just want to introduce a couple concepts since we're going to be talking about automated vehicles, and not every automated vehicle is the same. So we're just going to give kind of a brief background about what we mean by automated vehicles, introduce the connectivity term to it, the whole connected automated vehicle, and then really go out on, or maybe not necessarily that order, but I'm also going to go out on a limb and say, hey, what's reality? What are we really looking at for when these vehicles are going to start hitting the streets? You'll see that's after I retire, so I can't be held to that answer. So as we start off with, courtesy of our colleagues over at the Society of Automotive Engineers, this is a brief background about what we mean by automated vehicles. So not every automated vehicle is the same. There has been different levels. The industry, the auto industry, the transportation industry, for years we're kind of struggling with how to define an automated vehicle. You actually had two different classification schemes going on there, and really started being confusing. So in perfect engineering wise, we have 6 levels of automation that go up to level 5. Go figure that one. And I say that because level 0 is actually an automation. But this is what describes how functional, how capable a vehicle is from an automation standpoint. The large majority of vehicles out there right now are what we call level 0 automation. You have no automation at all. I've got a 2018 Ford vehicle, just bought it. It's wonderful, got a lot of technology, could do a lot of cool things, can warn me when something's behind me, back in front of me, great camera views, but you know what? I still have to be driving it all the time. That's still a dumb vehicle in level 0 automation. Okay? So that's the vast majority of vehicles out there right now. Level 1 automation, if anybody has a newer vehicle with adaptive cruise control, where you can start taking over some of the decision making. There are a lot of those equipped vehicles out there now. That's level 1 vehicle, level 1 automation. Again, that's a smaller proportion of vehicles, but there's more and more of that type of automation out there. Level 2 automation, which seems kind of low on the scale, but that's really almost the highest level of automation that's out there in passenger cars right now. That's the, in some instances, the much maligned Tesla Autopilot. Much maligned, but it's just an awful name. It's a great system, awful name. There's General Motors Super Cruise, Mercedes coming out with a level 2 system. Basically, what a level 2 system does, it takes over more than one driving decision. And taking General Motors Super Cruise, it takes adaptive cruise control, marries it to lane keeping, so you can pretty much put it on a highway and it'll drive itself in most conditions. You still have to, the driver though, still has to be under complete control of that vehicle the whole time. We're going to skip level 3 for a second and I'll let you know why. Then we get into the higher levels of automation, so level 4 and 5. Those are what we call highly automated vehicles. That's what most people think about when we talk about automated vehicles. These are vehicles that you can program, can drive themselves for the most part. The difference between level 4 and level 5 is level 4 means it can only operate in fully automated mode, the vehicle making all decisions, driving decisions, navigation decisions, but only in certain environments, whether weather's ideal, if it's a geofenced area. That's what level 4 vehicle, and that's a lot of the vehicles that are out there right now as demonstration vehicles are level 4. Level 5 is the panacea of automated vehicles. It's where I can sit here on my phone, dial a ride, it's got no driver in it, pick me up, go to Burger King to get my shake or McDonald's or what have you, do whatever. That's level 5. There are no level 5 vehicles on the market right now. There are some vehicles that have full autonomy, but they're transit vehicles. They're low-speed vehicles that could go below 25 miles an hour, but those level 4 type of automation, mostly on trial prototypes. There's very few of them actually in revenue service. So I wanted to kind of clarify why I skipped level 3. Level 3 automation, by definition, is saying the vehicle has complete control over all the systems until it gets to such a complex situation, a computer can't handle it, so it switches over to a driver that hasn't been paying attention for the last 10 minutes. So there is some debate right now whether level 3 even makes sense to pursue from a system standpoint. And a perfect example of that, I'm sure folks have followed well, maybe not, but you might be aware of the crash in Tempe, Arizona, where an Uber vehicle was involved in automated mode in a crash. The point, I'm not going to get into what went wrong or right or speculate, but what's very clear in the videos that were shown is that operator behind that wheel was not paying attention. So to me, that kind of shows the fallacy of relying on a human operator to take over if you get to a point where a highly capable automated system can't. So I'm going to skip over level 3. So most of our discussions, when we have our discussions later on, we're really going to be focused on level 4 and level 5. So now the reality check. When are level 4 and level 5 vehicles going to be out there for us to purchase off the dealer lot? So we'll go through a little Big Ten math. If it's wrong, I'll say it's University of Wisconsin math. If my math is right, I'll say it's Penn State math. So right now, like I mentioned, you can get some level 4 type vehicles in a transit sector right now in 2018. But really, worldwide, there's only about maybe 100, 150 of these vehicles. In the United States, there's about 24 of them that are either going through pilot processes or pilot deployments or demonstrations elsewhere in the country. So you can get them right now, but you still don't have any level 4 or 5 capability passenger cars that we can buy ourselves. You take the most rosiest estimate from an automaker or technology company, said, you know what, I'm going to have a level 4, level 5 vehicle available to you by 2023. That's a pretty bold statement to make. I personally believe there's a lot that still has to happen. There's a lot of complex situations, we're going to talk about today about access management that have not been nailed down yet. But whatever, we'll take that prediction for what it's worth. We'll say, okay, first level 4, level 5 vehicle that any of us can buy off the dealer lot is going to be 2023. Well, like most automobile technology, whether it's automated systems, whether it's cruise control, whether it's air conditioning, stereos, they all start at one point at the higher end vehicles and are expensive options, and it takes many years to get through where it's a viable option for vehicles throughout the vehicle fleet. So again, a rosy estimate saying if it's introduced 7 years, the technology becomes on most vehicles you can get. So okay, let's say 2030, we have a reasonable chance of buying one of these vehicles off a dealer lot. Now you look at the fact that the average age of the median age of the vehicle, passenger vehicle fleet out there is 11.5 years, which means roughly every 23 years, there's about 80% new vehicles on the market. Okay, so you start putting all that together, you start doing, this is where the math comes in, you start adding all those numbers together, and we're talking 2053, again, that's after I retire, so I'm not going to be held to it, 2053, so let's just say 30 or 40 years before we're to the point where we have so many of these highly automated vehicles, we could start changing our design decisions. Now, am I saying that from a negative standpoint? No, I think it's great. I love the technology. I'm really bullish on it. We got a plan for it. Can't wait for it to be there. But the fact of the matter is, for the next 30 or 40 years, we are very much going to have to design for still us all dumb drivers behind the vehicle, and even more challenging, the mixed vehicle fleets where you have dumb drivers intermixing with very smart vehicles. So that is the reality, and that's what we have to keep in mind when we start planning, talking about access management, that yes, we have to start planning for the automated vehicle, but even more important, over the next 20, 30, 40 years, we have to start planning for these mixed vehicle fleets. So the last thing I want to throw in there is a lot of what can get us over that hurdle. We don't want to wait 30 or 40 years before we start getting all the benefits of technology, and that's where the connectivity comes in. You heard the terminology connected automated vehicles. So automated vehicles are by their definition, they're very smart vehicles. They know they have some levels of artificial intelligence to them in some instances. They're fully equipped with a lot of sensors. I think you'll hear John probably talk a lot about, or knows a lot about that too. lot of smarts behind the vehicle, but they only know what's around it. You start having that ability to exchange data and communicate back and forth with other vehicles and with the infrastructure, and that's the connectivity side. And that's where we can start getting the benefits in some of the scenarios we're going to talk about here this morning about maybe automated vehicles can't handle some of the scenarios, but you start adding a connectivity component to it. We can exchange data and information, and we might be able to handle some of those more complex scenarios. So lay the groundwork for some of the discussions we'll have here this morning.
Great. Thank you, Matt. Sure. So our other panelist, John Riehl, just to give a little background before he provides us some background on the his work. John's a transportation system engineer here at the University of Wisconsin. He's also involved in the leadership of the Wisconsin Connected Autonomous Vehicle Proving Grounds, and he's going to talk a little bit more about that. Has a lot of experience both in the classroom and in the research side, a lot with TISMO and ITS and GIS. John is a proud Michigan Tech grad, and with that, I'm going to have John skip a slide here. One more slide. Do you have the clicker? All right. And talk about what they're doing out at the Proving Grounds on connected autonomous vehicles.
All right, great. Thank you. Can everyone hear me? Okay, so first off, thank you for having me. When I got asked to come to this conference, I was thinking, same thing probably a lot of you were, how the heck am I going to talk about access management and automated vehicles? I hadn't really thought about it too much. I teach a class on highway design. We talk about access management. We talked a little bit about automated connected vehicles. And it gave me some idea of maybe where we might go. But once we started having our discussions, I started realizing how big of an issue AVs and access management, kind of how they mesh together. And honestly, this is going to be one of the most interesting discussions that I get a chance to be a part of regarding this technology. So I'm going to start out talking about the AV proving grounds. There are 10 designated by the US DOT proving grounds across the country. We were lucky enough to be designated as one at the university, and we branded it as the Wisconsin Automated Vehicle Proving Grounds. There are partners across the state working with us on this. The 9 other sites, the sites are very different in scope. Probably the one, Matt, you're probably familiar with the one over in Michigan. That one, it's a great facility they've got. They've revamped everything at the old airport that they have there, and there's a lot of great work being done there. There's a specific site where they're doing that research. M-City is slightly different. It's not considered one of the proving grounds, but they've been at the table to the various meetings we've had because a lot of the work they're doing is also involved with this. But then you start looking across the country and you say, well, how the heck are all these different groups working towards this same objective? You've got the extreme of, in Maryland, Aberdeen Proving Grounds, which is a military test site. Contra Costa County is probably one of the ones that is up there in funding by private sponsorship, so a lot of different testing on their main facility. Then you have some of the other ones like Wisconsin, where we've got a whole bunch of different things we're working on, and we're not really just working on the technology piece. We're trying to look at all these broader implications, hence the discussion today. So what are we doing here without trying to make too much of a plug for what we're doing to sell it or anything, but just to talk about kind of the ideas so that you can see how and where this might intersect with what you're doing. So we basically work from simulation up to full public road testing and everything in between. So simulation, we have a simulation team that's working on first just getting a simulation working with connected and automated vehicles so that we can put whatever percentage we want out there on the road, see how they interact with pre-programmed human drivers, if you will, and see how that interaction works. Then we have a driving simulator. A lot of the human factors research gets done there. So we talk about these drivers who aren't really as good as the automated vehicles, but in some cases maybe they're better. One of the things they're definitely not as good at is paying attention. So distracted driving, we do a lot of tests with the driving simulator to see how and when they take control when they need to. Say they have a level 4 vehicle. Level 4, you're not necessarily supposed to take control often, but there is still that possibility, whereas level 3 that we talked about, certainly there's going to be those cases where you will need to take control. Even with level 2 in Tesla, all of the crashes you've seen with Tesla have dealt with distracted driving and taking back control when needed. The vehicle is generally figured out and warned the driver that they should be paying attention, but they're not. So then getting into the lab, we have some test vehicles, smaller vehicles, just to do some application testing and the different various research models that go into the AVs, and I'll spare you of those for now. Closed track testing, this is probably why we were selected as one of the proving grounds. We actually have a facility over in Burlington, Wisconsin, called MGA. It was started as an American Motor Corporation's, I think it was the birthplace of the Jeep. So they tested those there in the 70s. Once that turned over, MGA got a hold of it, and they do a lot of the crash testing, the standards that you see on the vehicles and the 5-star ratings and whatnot. That's what they work on. They're already working on how do you deal with a crash with an automated vehicle. If people are all looking at each other, how do the airbags even help in that scenario? Or do they hurt? What do we have to do? The whole system gets turned on its head. Controlled demos. So we had a demo of an AV shuttle here in Madison. Did anyone get a chance to go out to that? Any locals here? No? One. Yeah, Andy. Thanks, Andy. So that actually worked pretty well. I think we gave about 750 rides, and it looped around a little portion of the campus there just to get people aware and to ask questions about the vehicle and kind of understand the technology a little bit more. That was a level 4 vehicle, just to go back to the SAE levels that Matt was talking about. Then limited facility testing, where we have a section of roadway where we can either close it off or it's a limited use so we can use it at a certain time. And then all the way to the holy grail here, which is public road testing. So you can see there's a wide spectrum. This, I won't spend too much on this slide other than to just show you there are a lot of different things going into the facilities we use for the proving grounds. So the MGA facility is there in the picture in the top right. That's kind of hard to see. Also, Road America is a part of this as well. They already had a vehicle from Michigan Tech down there doing some AV testing for it was a student program that they had. You'll also see in the middle there's an AV CV corridor that we're working on here in Madison, and the CV portion is probably the most mature at this point. I'll talk a little bit more about that in a second. So I talked some about the breadth of the research, so I'll skip over the things I already talked about, but just to show you kind of the areas what we might be thinking about. There's really a breadth of research areas. We have this diagram that shows about 20 or 30 different areas that really could be interesting with automated connected vehicles. What are we focused on? One of the main things we've tried to do, if you noticed, I don't think it was on the slide, but the AV Proving Grounds didn't come with any funding. So the first thing we did is we went out to government and industry, and we talked to them about, well, what do we need to do with this? And there's actually a lot of industry partnership going on and government partnership with all the different proving grounds, and trying to work together to move this forward in the right way and not just move it forward because we want to move it forward. Automated shuttle corridors, I mentioned a little bit. We're working on a couple of them here in Madison now to do some testing, some short routes where it's a little bit too long. You might not want to walk that distance, but it's too short to really get into your car and drive and try to park again. A good example here in Madison is the East Wash area, Near East. That area is booming. There's a lot of different things going in there. And the connection to downtown, there's a nice hill you have to walk up if you want to go to lunch and you work down there. It's not necessarily something you're going to do in 30 minutes, but you could get into a shuttle that would take you up there and it would work for you pretty well. You wouldn't have to deal with parking. I'll talk a little bit about the connected corridor. That one actually, we have some units on that on Park Street here in Madison. We have 5 of them right now, roadside units on the road at the intersections. We just had an onboard unit put on one of our department vehicles so that we can actually talk with these signals and we can start the testing of all the different ways these are going to communicate with AVs or even just with regular vehicles for the time being. I find connected vehicles to be, at least in my career, the most exciting right now because I think that's where in the next 10 years we're going to see a lot of development pretty quickly. And it'll also be something that feeds into access management we'll talk a little bit more about later. AV and CV simulation, I talked about. AV traffic flow theory, we've got a lot of traffic flow theory people at the university, so obviously we've got people working on those sorts of projects. Truck platooning is one that you might have heard of. There's different scenarios on how you might access the roadway if you have a truck platoon, things like that. Human AV interaction, I talked a bit about that. And then engagement and outreach, it's really why I'm here today. We do outreach in I've presented to a wide variety of different groups across the state and nationally, and it's just exciting every time. So with that, I'll turn it back.
Great. Thank you, John. All right. So back to, again, what's access management and connected autonomous vehicles have to do with one another. So we're going to do a little test again with your next door neighbor to the right and to the left. I'm going to ask you 2 questions, and you got to tell your neighbors what you think the answer is. Okay, we're going to do a little bit of, you can wager a bet if you want, or just your dignity, one or the other. So, first question. Is a 11-foot or 12-foot lane safer? Okay, that's your first question. And then your second question is, if we go out here on State Street mid-block and you walk out in front of a car, will it stop? And the second question is, if we walked out in front of a level 5 car, would it stop? Okay, I'm going to give you 30 seconds to answer that question with your neighbor. Then we'll ask these 2 guys.
The discussions, the one thing most people don't even, the different levels.
All right.
Yeah.
Let me get your attention back here.
It's all just only going to be a good thing.
All right. Okay. You guys ready? Got the answers? All right. I'm not going to put any pressure on Mike. He's a little nervous. I'm standing here, but we won't talk to him exactly on this. All right. So that first question, how many people said 11-foot lane safer? Okay. How many said the 12-foot lane safer? All right. How many said there's no difference? All right. Those people have the correct answer. So one of the things that's pretty unique, and the reason I bring this example question up, is it takes our industry a while to agree on things, okay? So the Highway Safety Manual, which is, what color is the Highway Safety Manual? Yellow. All right, we got some people that know that. Actually, when that was published, it basically showed research that there's not really any difference between the safety between a 12 and 11-foot lane. Well, obviously, we have some people that should go to TRB and buy a yellow manual, both on 11 and 12. But it takes us time. So when we look at connected autonomous vehicles and access management, the same thing. It's going to take us time. So as Matt was saying, 2053, it sounds, oh, that's not my problem. It's like, yeah, it is our problem, because we have to start planning, permitting, designing with some of this in mind. So as they do come along, we're not trying to build ourselves out of a problem. So that second question, if we go out here on State Street, and we'll test this tonight. So we'll go out there, and I'll say go, and we'll see. And then Matt will bring one out from the proving grounds, and we'll see if it stops. But if you go across mid-block, what's the odds that that car is going to stop? No, that's true. See, some people are local here. There's the bus, though. The bus will come. What would happen with the bus? It would not knock you over, and you'd be done. However, as a society, we have a social contract, okay? That car knows that if we step out, that's kind of our fault. If there's a crosswalk there, then theoretically in some parts of the nation, they're supposed to stop for you. But there is a little bit of a social contract. So, Matt, what is the social contract between the level 5 and the human?
So by definition, a level 5 vehicle says there is no input from the operator behind them. All right. Definition is an operator. But the person getting in the vehicle for the ride, by definition, is not going to have control of that vehicle. By definition, a level 5 vehicle might not even have a steering wheel. So the social contract, I would imagine, isn't so much from the driving standpoint. It's going to be more on the safety standpoint. Hey, if I dial ride, am I going to clean up after myself? You know, am I going to take my soda? Does it pop up here too? I know it's pop in Michigan. It drives me nuts. I'm an East Coaster, so soda. Okay, so did I take my soda can of soda? I think that's more where the social contract is going to be, is interacting with the system rather than driving, actually operating the vehicle.
Right. So John, what's that vehicle going to do on State Street when you step out?
Well, it's an interesting, I actually have a slide in some presentations, so it's called How to Defeat Autonomous Vehicles. I think that the level 4 vehicle that was here on campus, for instance, that one would stop, and it'll stop hard on a dime to make sure it doesn't hit that person. The problem is, once I know that and 10, 20,000 students start to learn that, and they're late to class, they're going to exploit that, right? So clearly there's got to be some middle ground. The vehicle's got to be assertive enough to figure out which situations make sense to stop and not, so that contract that we currently have still has some sort of meaning later on, and each are treated kind of equally.
Yeah. So that's it's an interesting thing. We talk about the evolution of our profession, and we just talked about two things. One, what's the research telling us? And then two, this more social, political type of element, and we'll get more into this as the conversation goes on. But just to kind of bring this full circle, so you're like, I didn't just waste an hour of this conference on connected and autonomous vehicles. It takes us between research manuals on access management, 2003 to 2014. That's the cycle on which we publish a new manual. So we're probably not going to have a new access management manual, unless Neil over there finds us some money soon from Federal Highways, is probably 2025, maybe longer than that. So a lot of this stuff we need to start now. So we're starting to think about research, we're starting to think about problem statements, and you're starting to see these populate. So we'll first start with access connections, and then we're going to move on to curb access. So with that, we'll go back to our example here, the A and B example. And with that, John, I'm going to start off with you. We have a two-way left turn lane there. How does the autonomous vehicle deal with that? And you can talk about the levels and so forth, but give us a little understanding of that.
Sure. So it depends, right? How do we deal with that? Think about the last time you've turned into a left turn lane. Probably you were fine, right? There was no one there. You just went and made the turn. But how many of you have had a situation where you wanted to go left, the other one was coming the other direction and wanted to go left, and you had to do something? Has anyone had that conflict? Many of us, right? So the first question, or to answer that, you have to think, well, what did I do in that situation, right? So there's good things to do and bad things to do. We certainly don't want the AVs to do the bad things, but is stopping the appropriate choice? Is that going to allow the turn to happen? Is that going to mitigate a crash? Maybe in certain situations, and others not. So it's very complicated, the answer, and I guess different companies are approaching it different ways. I can say that certainly AV manufacturers, so you think of someone like a Waymo, which would be the Google spin-off autonomous vehicle, they're certainly thinking about these algorithms. They're doing machine learning to basically throw the vehicle through different scenarios. So every time you've ever made one of those lefts, it's in your mind, and you kind of already have that scenario modeling in your mind, and maybe you were building it since before you drove. You were paying attention to your parents or other drivers for either good or bad examples, right? So you've built that in your mind. It's the same thing with these AVs, but if you put them through these different scenarios, they can maybe decide better what to do. So it's not a great answer to that question. I didn't say exactly what they do, but it's complicated, and it's one of the cases we need to talk about.
Right. So Matt, let's maybe take it a step further. The vehicle is now in the two-way left turn lane, and it's trying to figure out what access do I use. Walk us through that scenario, kind of where we are, and maybe the issues that are currently still being resolved within the industry.
And that's a great point, a great scenario. And before trying to answer the question, just to kind of compound about the issue, if you look at the transportation network companies, the ride-hailing, Uber, Lyft, or everything. Just yesterday, for example, I was in downtown Pittsburgh, called up for a ride and said, okay, I want to be picked up here. It's a hotel, it's got an address. But it was showing me, at one location, and the car's unit, the driver's unit was showing to pick me up somewhere else around the block, and ended up having to go around the block 2 times before able to figure it out. So I guess where I'm going with that is it's a very real issue when you have multiple parts, multiple ways, multiple paths to get into a single access or a single address, a single place. It is going to be very complicated. The hope is, like John had mentioned, the algorithms, the machine learning, the artificial intelligence, which is really the only way these systems are ever going to mimic the driver behavior. You can't program in the almost infinite amount of scenarios that these vehicles might run into. And you have to hope that that machine learning and AI is going to figure out, okay, where are, what's the traffic going? Am I going to have to turn, is it predictive enough to know I'm going to have to turn left here because two-way left turn lane is going to be nuts, so I might have to go down a street and turn left and turn right or what have you. One of the challenges is going to be is, do I go counterclockwise to get my shake? Or am I dropping this guy right off to go on a walk where we can use the restroom and go to the counter too, which is a different driveway. Now that is one of those instances where I don't think we're going to have, there's going to be an easy answer to that because there's, like I mentioned, an infinite number of scenarios where that can happen. It might be one of those ways where the users, if they want to, say that the owners here, they say, hey, I want people to come here. That's where some of that connectivity and apps and everything that can be run on phones or run on board the vehicles, that's where they can start getting involved, saying, okay, right now a user can get in there in Uber and say, someone wants to pick up, make sure it's here. Airports do that all the time. You might see that same way down there. That's the only way it's going to solve it. I don't think we can rely on each individual vehicle to figure that out.
Well, maybe taking that one step further, John, as you guys have been out on the proving grounds testing vehicles, we have the example there of example B, and let's maybe take that one step further that it is one-way circulation. So we have diagonal parking in there. It's one-way circulation, counterclockwise because they want to maximize their shake sales at that location. So as we look out here and we have permit specialists, how they permit those driveways, and then designers on how they might design that driveway. Walk us through a little bit how the vehicle itself is going to react, and then maybe some possibilities on from a design standpoint how we could help the vehicle take the right way and potentially not go counter or clockwise within the site.
Sure, it's a great question. One thing I'll mention too, we talked about the levels of automated vehicles, and you had level 4 and 5. I like to talk about the level 4.9 vehicle or 4.99. A lot of these edge cases, as we call them, something like this scenario, are the ones that aren't really being solved right now. So if I can get my vehicle onto a highway and I can take my hands off and it drives perfectly for me, that's going to solve most of the problems for my driving needs. Or if I can figure out how to at least navigate through the city, I can give back control when I need to get to my destination. But ultimately, a level 5 vehicle needs to solve this problem. So you talk about the one-way circulation. Well, the best way, the easiest way for the vehicle to know that is to know which one is the one way that they need and which way is not. That can be done in a number of ways, but that's where I think the connected vehicles actually, as Matt mentioned, are kind of where this might happen first. So talking about a connected vehicle at an intersection, which is what we have here in Madison, and there are many of those across the country now going in, and probably something that many of you will begin to get interested in. There's different messages that can be provided. The one really interesting one for access management is the map message that actually gives the map of the intersection down to which exact lanes go where, what the sizes are, and the access methods for those different lanes and everything else. Are they one-way, two-way? At an intersection, we're working on that problem. There are a certain number of intersections, right? In Madison, there's on the order of 300 signalized intersections. So 300 is a number that we could say, well, eventually we could probably put 300 signals basically at every every traffic signal that will send out this message and everyone will be fine and know exactly how to get through it. Well, how many of these different, if you drive up East Washington or anywhere else in kind of the sprawl of pick your favorite city, there are so many different places you could turn into, right? And they might have these different problems where they're one way. And we have those problems too. How many of us have turned into the wrong direction? I'll admit I have done it. I'm sure many of us have done that, right? And what do you do in that situation, right? So you want these to avoid it. So maybe what happens is the different, McDonald's has Wi-Fi at every location now because people want it. Well, if I'm taking my Uber vehicle there, well, maybe as part of that, it sends out a signal that can then be connected via the rest of the infrastructure to the vehicle so they know where to go.
Great. John, well, and maybe building on that, Matt, the issue is, okay, we got in the two-way left turn lane. We found our way into the right driveway. Now we're on site. Walk us through kind of, as engineers and planners, either we're working for the developer or we're working for a review agency, throat distance, driveway width, parking lot circulation. Matt, what do you see as things that we should be starting to take a look at, maybe a little bit more in depth and potentially helping or mitigating down the future with connected and autonomous vehicles?
Okay, well, I'll start with the longer term, maybe work our way back in. Longer term, even beyond 2053, is your whole concept of parking needs are going to change dramatically. If you get to this vision where a level 5 vehicle means you're not personally operating a vehicle, maybe it means you're not personally owning a vehicle. Maybe it means the cars we own right now that sit unused 95% of the time, essentially one of our most expensive assets that we're only using 5% of the time. Maybe they're becoming more efficient and we're using one car the whole family, or we're sharing a vehicle, what have you. All of a sudden that vehicle gets a lot more use and doesn't need to be parked as much. So conceivably the whole concept of how much parking is even needed for land uses is a very real conversation. Now what you might have in this scenario might be different than, say, if you have a downtown office building. Downtown office building, if you have a dial-a-ride service with no operator or driver, conceivably, do you need downtown parking anymore? Can it be remotely parked? Or are they even going to be parked? Are they going to be circulating, just going from here to there, serving different customers? So that's really down the road to think about, but really we've got to keep in mind that the whole, even the concept and need for parking is going to change down the road. You look the total opposite end, which is very near real term. Most automated vehicle systems right now are vision-based, or have vision-based components, I should say. There's all sorts of sensors that, what have you, radar, LiDAR, what have you. But there's a lot of vision-based, machine vision-based sensors. And they work on clarity of signs and pavement markings. So if you have a parking area that you want the vehicle system to be able to know what's going on and have situational awareness, so to speak, it's got to be able to rely on the pavement markings. And we all know how easy it is to maintain pavement markings in northern tier state, right? It's, we all know how that goes. But so that's a challenge. But that's a very real near thing that the discussions can start having today. The other scenario, first scenario is longer term, but you can start having discussions today. How, what physical features and assets do we have on site to assist with the driver vision systems? When it starts coming from planning and layout, and it gets a little more complicated, because again, we have to keep in mind what I mentioned before. Over the next 30 or 40 years, we are designing and planning for a mixed fleet. So we have to be careful about making decisions just for automated vehicles in the short to mid-term, because we're still going to have I say dumb drivers, and I include me in there, because all drivers are not smart at some point or other. But we still have to incorporate that mixed fleet. So I'm going to say we don't make any changes down the road, but let's start looking at the physical assets on site and can help out with the vehicle systems.
Great. Well, John, maybe just to get your thoughts on that. What do you see as, DOT, state and city officials? What should they might start to think about access management policy and design as we look at driveways and new development that starts going in? What thoughts do you have on that?
Yeah, it's an interesting question. A lot of you might be saying, well, it sounds like maybe we don't need to do too much, but I think it's thinking ahead and saying, is this design that I'm currently looking at going to be adequate for a level 4, level 5 automated vehicle? The two-way left turn lanes, I think, are a great example of that. So we've decided that two-way left turn lanes work pretty well in certain scenarios, maybe not so well in others. There's that trade-off between especially when you have a situation where you'll only have one lane in either direction and have that center lane versus having two on either side without that. And we all know the trade-offs there. But do those lanes make sense for AVs in the same situations? Can they use them in other situations? Can they use them in the current situations that we have them designed for? I think that's going to be where you guys will all be thinking about this over the next 10, 20 years, is really maybe it's not driving the decisions, but it's in the back of your mind, how is this going to affect an AV, or how well can it deal with that? I think that's really what I'd like to point out.
So the other thing I'll throw out there too is a lot of road features out there, two-way left turn lanes, what have you, are all, even lane widths, are all to accommodate the driver behavior, driver error, human error. You start looking at vehicles, those level 5 vehicles, when you predominantly have them, level 5 vehicles out there, it might just completely shift how you think about access management and traffic flow and what have you. You take, for example, anyone here familiar with the Michigan left, which is great for traffic movement, but can be very difficult for access management, depending on where you're coming from access management. For a road operator, it's great for access management. For a business owner, maybe not so much. But all of a sudden, you start removing the need for having those decisions with two-way left turn lanes, and you can actually channel folks to say, okay, it was a joke, I'm going to turn right to turn left. You start going through those Michigan lefts and start channelizing vehicles. Maybe there's other things you can start thinking about that are much more efficient when you don't have to worry about the human error and the human decision. And that's, I think, what we can start looking for is start planning for how 30, 40, 20, 50, 30 and beyond, can we start looking at that and do those negative connotations with those types of solutions go away because we don't have a human behind the wheel.
Great. Well, I think I'll wrap up this session, but just a few things to think about. We've talked about the connected vehicle. How many of you have the Starbucks app on your phone? All right, so it's not just in the Northwest where we like our coffee, but has anybody used where you can order your coffee and you just show up and it's there? Have people done that? All right. So what Starbucks has been doing is in their drive-through facilities to minimize the length of the drive-through and just the site and the dimensions that they need, they're really pushing that app. And what it's doing is you're seeing more people that come to the site, they'll park, go in, pick up their coffee and leave and not in the drive-through because it's quicker to do that. So they've changed how we react and ultimately how they design the site. So for you consultants out there that work with developers, and then on the flip side, if you're on the pre-apps, start talking about connected autonomous vehicles and technology, because a lot of times it can save the developer real estate space instead of putting in a 100-foot, 200-foot drive-through. They can maybe minimize that to 100 feet because the technology allows them to process things more. One of the other ones, another example, getting back to Matt's point, that's changing is a lot of parking structures in the U.S. today. You can't get financing for parking structures that can't be converted in the future to office space. And the reason is, just what Matt talked about, is investors right now are worried about the long-term viability of parking garages. It used to be you went to a bank and said, I want to build a parking garage, and like, all right, we're going to fund that, no problem, no how. But right now, I know, for examples in Portland, Seattle, and the Bay Area, you try to build a parking garage, you better be able to show the banks how you can convert that in the future to either mixed use, retail, or residential. So that's coming. Same thing on access management. So start thinking on your policies, how you're permitting things, how you're making things look, and talk to the developer. We might be able to make your site more efficient because in the end, there may not be any parking spots. It may you be drive through, pick up your burger, and you're on your way, and that's it. You don't need any parking for employees because they just get dropped off. So it does start to change, parking maximums, parking minimums, and a lot of other things that we deal with in that realm, as well as the access itself. So next element, curb management. And how many, there wasn't many people that knew much about curb management. Again, show of hands. All right. Man, you're going to go home and talk to your spouse about curb management. Your kids, they may not even know about it. So I thought that might be the case. So I wanted to give you guys a little bit of background before we jump into this discussion. So if we look at the last century, since we converted from the buggy and stagecoach, we've really been doing two things at the curb: parking and loading. And generally, that's what we've done, and we've been doing it for the last century. You know, we've kind of updated. You know, we brought in the Model T, updated the buildings a little bit, but we're still parking. We're still loading goods and information, or goods and people. Well, that's, you know, the movement of people and goods, and we're parking them at the curb and we're loading them at the curb. And now we even, you know, we have our Teslas, and we're still doing that. But things are about to change, and they are changing fairly significantly out there. Any people from the Bay Area? All right. It's a great place to go, but we'll talk a little bit about what they're experiencing and some of the issues that their policymakers are having to deal with right now in terms of access to the curb. So one of the questions is, what do we first use the curb for? And you're going to go, well, Mark, you just told me, parking and loading. Well, that's not the same case anymore. Some of the things that Matt and John were talking about, parking may not be the highest and best use for the curb. So what are the competing factors? Well, we got the parking lane. We got that loading and unloading. They've been there for 100 years, and they've been pretty efficient. But now we're starting to see, well, maybe we want to convert that to multimodal because we're running out of capacity. We want to get more people into the downtown areas. We need to open up capacity. So one of the questions is, do we just get rid of that parking and loading altogether along that curb? Another is, do we convert it to cycle track? Do we go to a park space or parklets and rent that space out to restaurants? One example here is between 5 and 9 o'clock, anywhere in America, how much revenue do you think a parking space on the street can make? Any guesses? Most cities, it's under $10. Do you know how much a restaurant would be willing to rent out that space to add another 5 or 6 tables to their restaurant during that same time? 200, 300. There's a few places in San Francisco right now, $500 for 3 spaces. So the city's like, well, maybe we'll give this to some tables in the evening versus having parking there. So that access to the curb, another question. Street patios, so we come in with that. Ride share. Here's where the problem sits. Back to that scenario we talked about earlier, the TNC or the Uber or the Lyft, it's taking you to dinner. You want to eat at that restaurant. Now, where does it drop you off? So the question becomes, okay, is it travel lane? Is it what one of those? And what we're starting to see is the amount of pickup and drop-off is increasing rapidly. You look in some communities, for instance, in my hometown, when the theater district gets going, there's Ubers lined up 5 blocks back trying to drop people off. They're double parking, triple parking, and if Broadway had another lane, they would quadruple park because that's what's happening there. And as a result, Uber and Lyft are actually going to cities like San Francisco, Portland, Seattle, DC, and asking, we want to pay for access to the curb. Okay? We want to pay for access. You wouldn't think Uber's coming to say, well, pay for access. Why are we paying for access? So we're going to start this discussion because a lot of the things that we're talking about access management, access to the curb, those same conflicts, they all exist. So this part of the discussion, we're going to talk a little bit of what's going. So just to summarize there, loading's going up. Why is loading going up? What's that company that's looking for a second headquarters? Amazon. So actually, loading's going up, drop-off's going up, parking is going down. Some cities are now losing parking revenue on street, not just the garages, but you're starting to see on-street revenue loss. And what's the demand? Connected autonomous vehicle is raising, and the access to that curb is becoming fairly problematic in some communities. And as more of these vehicles introduce themselves, that's going to become greater as time goes. So back to this question, circle back to our panelists here a little bit. So Matt, first question, obvious one I asked earlier, what if the connected autonomous vehicle can't get to the curb? What happens?
Well, that's a great point, because as you mentioned already, Mark, that's a very real scenario, happens now. And there's a couple different ways of looking at it. It is, if you're in a dial-a-ride scenario, an on-demand scenario, take, for example, the scenario I just said before, where Uber drivers trying to pick me up at a different place I was standing because their systems were telling them different things. Well, hopefully maybe there's an ability there to start adjusting, say, okay, you know, and some kind of interface between the occupant and the vehicle itself. Say, okay, you know what, no, you're good to stop here. I know I asked you to drop me off here at this address, but just stop right there. There still has to be an interface between that operator or the vehicle itself. Otherwise, you're at the mercy and you're going to be sitting at that curb space, what have you, for an indeterminate amount of time. So that's part of it. And the other part is, so that's from the vehicle and operator side. I think the other part to help mitigate that too is on the planning side, is on and I might be jumping ahead there, but still want to point out that there is something to be done from the transportation operator side, from the planning side, to help designate some of these loading areas. You know who does a phenomenal job of curb space management? Or airports. Who's been at an airport lately who say, okay, Lyft, Uber, you're here. Bus shuttle, you're here. Now granted, they have very long curves, the curbs they can deal with. Or you know what? Picking and dropping off, no, not right here, because one of these police officers are going to harass you until you go to this area. They do a wonderful job with curb space management, because that's the only way they're going to maintain circular flow through the areas. That kind of aggressive policy and aggressive enforcement may have to be the same thing in order to handle the increased demand for curb access.
Great. So John, I know we're running out of time, but a little bit of thoughts. Once the car gets there, so let's say it gets on the curb, there's this loading and parking going on, there's people getting in and out. How does the vehicle get back into traffic with those conflicts that's presented?
Sure, I think it's similar to how does it get back into traffic when it's parked, or any of those types of scenarios. It's turning left from one of those driveways we saw. It's got to know its surroundings, which generally these vehicles will know better than we do what their surroundings are. They have their 360 cameras, LiDARs, everything else to see that, and then it uses that to figure out when it makes sense, and its gap judgments to make sense to get out. But in these cities where it's even more of these vehicles, and there's more incentive to take these Ubers, and they're lined up, you know, how far back did you say again? That sounded
300-400
yeah. So, I mean, there has to be a better way, right? So that's the first thing. I also wanted to point out just quickly, I mean, if you work for the city or for the municipality, it is your curb to decide what to do with. It's the citizens' curb, right? You have to think about it that way first. So cities like Washington, D.C. hired curb space managers to do this precise thing and think about that. As we see this shifting environment, we need to price it. It's a supply and demand problem, actually. We need to price it accordingly such that it makes sense for an Uber to drop off at a certain point and not at others if we don't want that. I think another place, we mentioned the airports, also busing. We kind of solved that problem pretty well. Buses don't stop everywhere, at least most of the major systems in larger cities. They stop at a fixed stop. But that stop also tells drivers that they can't park there. And I've been in many a bus where there's a car parked there, and bus drivers, rightfully so, get quite angry at those people and make them move. But you need to make those situations more rare. With these vehicles, that's an issue. There's also something we didn't talk about today, getting more into the multimodal, the bike shares, and the dockless bike shares in particular that you're starting to see in different cities. That's kind of an element of your curb too. If they can just park wherever the heck they want, that's going to block off retailers or anyone else from using that. Maybe you can't drop people off if there's a bunch of these bikes sitting there and they can't get out. There's all sorts of different scenarios that we need to think about. Great.
All right, so we're going to wrap up here, and I got two last questions for our panelists. But you know, if you are with a city or a county, but those with the city, you will have that question, and John just alluded to it, is how much can I pay you, city, to use that curb? Try to answer that question. Some cities right now, it's not only how much do I pay, but then by time of day, how much do I pay? So dynamic pricing and actually dynamic use of the curb, those two things are actually coming into play as we speak, which makes it a lot more complex. But again, access and managing that access to the curb is probably going to become, in 2053, the problem we have right now with the access connections, because how many people are actually going to go into the business versus potentially just drop off and continue on? So it's an internal, external access management problem that we really need to deal with. So maybe teeing that up. Last question, we talked, I think the secretary mentioned this earlier, access management's beyond just us engineers and planners, so you put the political element into it. Matt, how do you see this kind of playing out in the access management realm when you bring the design, but then the politics and the economics and everything coming? So put on your crystal ball hat.
So other than to say that everyone is going to have to come together, because there are going to be far-reaching aspects of it. Mark, you mentioned the economic standpoint of it. There's going to have to be some kind of policy. I mean, municipalities, in many instances, that revenue they get from managing parking facilities is huge. So just from the economic realities, even if you don't buy, which I do obviously buy into the access management from the safety and mobility standpoint, but if you don't buy into it, well, there's an economic component to it. Things are changing. There needs to be new revenue streams to help manage municipal services. If that central parking area goes away, maybe it's managing the curb, it's the aggressive adoption of renting curb space is the way to do it. So that it's really going to be a multi-disciplinary solution. Automated connected vehicles by themselves are multidisciplinary, but you start having these policies into place, and it touched on so many different areas. Some kind of comprehensive policy or comprehensive relationship building together is going to be critical for that.
Great. John, any last thoughts?
Yeah, I would say I liken this a lot to just urban planning and design. If you look back in the 50s, 60s, there were a lot of people thinking about designing cities in certain ways to mitigate things or make things better for people, mobility, access, pedestrian flow, everything like that. And not every city turned out the way that maybe they envisioned it or wanted it, probably because of this interplay between all the different elements involved. And I think with AVs, if Uber, what do they want? They want access to the curb so they can drop their people off wherever the heck they want, whenever the heck they want, right? Is that what we want as a city? Probably not. I mean, if we wanted that, we would have our buses do the same exact thing. So I think it's just thinking about this time period, even if you're not sold on the idea, or you agree with Matt that it's going to be 2053 or so until we even need to care about this. A lot of the planning that was done in the 50s, 60s, 70s made our cities what they are today. So a lot of the planning right now is going to make our cities what we want to see them like in that time period. So I think it's something we certainly, we shouldn't only just want to think about, but I think we have a societal need that needs to be thought about, and we need to understand it to make things better for people in future generations.
Great. And back to that question Ben asked me going into this session, what does this have to do with access management? If you remember that slide I presented, about an hour and a half ago, access management is about separating conflicts, speed differential. So a lot of the stuff we just talked about, same thing, different tools, different characteristics, but it is something that we're going to have to move forward with as an industry and figure out the policies, which now economics, we've talked about economics in the business. Now this is the economics of the livelihood in some instances of cities. You look at parking revenue, parking enforcement, that's a big piece of revenue for cities that could vanish relatively quickly. Talk about a disruptive technology, that's one in the making. And from an access standpoint, we need to be prepared to move forward with that. So at first, like to take a round of thanks to our two panels for sharing their ideas today. So Matt, John, thank you for your help.
Marc.
And while we sit up here in these comfy chairs, hopefully those chairs out there are comfy. These are pretty comfy, I'll tell
Right,
you.
fall asleep. Yeah.
But if you want to do a presentation, we'll have you come up and you can sit here and present for an hour and stuff. So we go into a break. We have about 30 minutes. So now you got two friends. So I don't want anybody out there standing alone. Talk to them. Talk about curb management. Learn something a little bit new today. Think about it. How's that play into policy? How does it not? Who's going to take the lead in that? I'm going to be talking to the committee this afternoon about access management taking the lead because it brings a lot of different elements together. Again, 4 o'clock this afternoon, the committee will be meeting. And with that, enjoy your morning break, and we'll see you back at 10:15.